In this video, we're going to look at another approach to establishing this identity. In the previous video, we started with the whole equation and we cross-multiplied. And that ended up working, but it took several steps. It was kind of complicated and tedious. So we're going to try something that maybe will be a little, work a little bit quicker. So I'm going to start with the left-hand side. Why the left-hand side? Well, because I noticed something that I think will make the whole thing easier. So I'm going to go with that, and we'll see how it goes. So I noticed I've got secant on top and bottom. And of course, secant is 1 over cosine, right? That's one of the reciprocal identities. So whenever I see this secant here, if I see secant, I really ought to be thinking of that as 1 over cosine, right? And if I would like to simplify this and get rid of that, make that term as simple as possible, and it is 1 over cosine currently, well, I can multiply by cosine to turn it into just 1, right? Secant times cosine turns out to be 1 because secant is the reciprocal of cosine. So I'm going to multiply top and bottom by cosine theta. Okay. So in the numerator, when I distribute this, cosine will multiply to this secant, turn it into a 1, right? Because again, secant is the reciprocal of cosine. And the cosine applying to this one will just turn this into cosine times cosine, which is cosine squared. So I'm going to end up with, this is equal to 1 minus cosine squared theta all over 1 plus cosine squared theta. Okay? And right away, the bottom is what I want it to be. 1 plus cosine squared theta. So the bottom's done. I just need to worry about the top now. You might recall from an earlier video where we did some examples where we had to deal with squared, sine squared or cosine squared. So we used the Pythagorean identity, cosine squared theta plus sine squared theta equals 1. And I can take that and I can subtract cosine squared on both sides. So sine squared theta on both sides. I may have misspoke there. Sine squared theta equals 1 minus cosine squared theta. That's a Pythagorean. It's a modification of a Pythagorean identity. That means that this numerator is sine squared. So I can write that equals sine squared theta all over 1 plus cosine squared theta. And that's what I wanted to show. Okay. So by starting with the left-hand side and noticing, oh, secant, that's 1 over cosine. I can multiply by cosine to get rid of that, simplify it. That's what allowed me to do this problem relatively quickly. The other one took several steps. It was kind of tedious. There's a lot of moving parts. This one much simpler. When you set out to prove one of these identities, you're not always going to see the easiest way up front, and you can't spend all your time worrying, oh, is this the best way to do it? Don't worry about that too much. Just try something, and if it works, great, and if it doesn't, try something else.